The question is solved for the addition of the zeros of the quadratic function y is equal to 3x squared minus 6x minus 4. And in the last time, we thought about solving this through a quadratic discriminant. And our ultimate question in this case was solving for the zeros, which is same thing with the x-intercepts. So if you review what we did from the first thing, that with the things that we had to know in order to approach this question was, firstly, we said that the quadratic function's basic format, which we call it as the standard form, was y is equal to ax squared plus bx plus c. And we know that if we convert our quadratic function into a graph on the coordinate plane, it will be a specific parabola that satisfies our own equation y is equal to ax squared plus bx plus c. The second thing that we did is each variables or constants, what do they do in the effect as an effect or influence in our quadratic function. Firstly, we know that the y and f of x is an output of our function. We know that in order to generate an output, we need an input. We notate our input as the x value. The x value will be the input of our quadratic function. And the third thing that we thought about was what is the a value. And as we can see, a was a coefficient of the x squared term, but in order to make a difference between just a coefficient and the a squared, we put the word leading, which is a short form to describe our x squared term. The coefficient of the leading term, which is leading coefficient of the x squared, will be a value. And the reason why it is one of the most important elements in the quadratic function is because we know that the types of graphs and the vertex is the most important thing in the quadratic function systems. And the thing that defines all of them will be our leading coefficient a. And the second thing was, what is the b? B is exactly the same thing with the a, except it is not a leading coefficient. It is a coefficient of the x to the first power term. And the last thing was, what is the c? And we know that c is a term without any variables, unlike the a or b, and we called it no variables as the constants. And it shows our y-intercept. And from the first thing, if you think about what does a value defines, it defines the types of our graphs, and the vertex depends on its signs. So there will be two cases because it depends on signs, whether it's positive or negative value. The first case will be when a value, our leading coefficient, is greater than 0. When the a value is greater than 0, which means it is a positive value, the graph of our quadratic function will open upward. And when it's open upward, you will never gonna intersect together with going upward, but it will contain one most important thing, which can be intersection between two lines, which we call it as the minimum or the lowest point on our quadratic function. And this will occur when our leading coefficient a is greater than 0. The second case will be when our leading coefficient a is less than 0. When it is negative, so which means when it is negative value, the graph of our quadratic function will open or go downward, unlike the first one. It is exactly opposite thing with the first one. And it is same kind of concept with the first one, where the two lines never intersect together because they're going in a different direction, but it will contain a one point, which we can say that it is an intersection between two lines, and we call it as the maximum, or sometimes we call it as the highest point on our quadratic function's graph. And this will occur when a value is negative value. And from here, from the types of our vertex, we could think about what is the definition of the vertex. The definition of the vertex is same thing with adding the number of possibilities between the minimum and the maximum point. And we know the minimum and maximum point will be dependent on the a's signs. So we could say that in a conclusion that the vertex is a stuff that will be defined by our leading coefficient A. And the second thing that we thought about is what is the types of the intercepts from the last one, which was the C in our quadratic function. But we could say that the intercept was the most important thing when it comes to solving this question, because our ultimate goal in this question is to solve the zeros. And the zeros is the same meaning with the roots in our quadratic function, which shows the x-intercept. So there were two types of intercepts. The first type was the x-intercepts. The reason why there are two types is because we know that the intercepts definition is the point. The definition of the intercept will be the point on the axis. And there are two cases of its intercepts, because there are truly two intercepts. The axis, which is the horizontal and the vertical axis, which we can sum it as the x or y axis. So this was the intercepts, and the first thing was, what is the x-intercept? The point is on the x-axis, which basically convert this into a coordinate. It will be x. When the x value, our input, exists, our y value should always be equal to 0. And the reason why we notate it as just an x and a y, not a specific value, is because they are the variables. The variables are the opposite meaning with the constant, where it never changes. So variables means it is a term that doesn't stay there forever. It is a number that varies all the time. The second one is, what is the y-intercept? Y-intercept is exactly the same kind of concept with the x-intercept, except the point is on the y-axis. So when the coordinate is on the y-axis, if we convert this into a coordinate, it will be when the x value, our input, equal to 0, our y value, our output of our function, will exist, and we just notate it as the y value. So our ultimate goal in this question was to solve for the intercepts, but especially the x-intercept, which they gave us the information as the zeros. And therefore, we talked about two ways to approach this question, how to solve the zeros. The first one was substitution plus factorization, which means we substitute our y value as 0 because it is a x-intercept, so the y value should always be equal to 0. Then we factor it into a binomials, and we solve for our roots, which we call it as the x-intercept, which we're gonna be our answer. But then this function, which was y is equal to 3x squared, so it was 3x squared minus 6x minus 4 was the unfactorable, which means we can apply the first one. And for the second one, which was quadratic discriminant, we were applying our formula for it. Quadratic discriminant was the way to apply our formula for it, and our formula was negative b plus or minus square root of b squared minus 4ac over 2a. There were two roots where they shorted with the plus or minus sign. But the good thing about the quadratic discriminant equation was that we could apply this at any times, and it is an accurate situation or the equation that we can use when it comes to solving the x-intercept. But bad thing about it is it took us long time to solve for it. So there are another way to approach this question, which is the most easy, and also it will gonna take 1/3 of the time that we spent on the quadratic discriminant. It is also an equation which we call it as the Vieta's formula. So we call it as the Vieta's formula, and this is one of the most revolutionary when it comes to solving the x-intercepts, the roots. Because it will probably take us 5 seconds if you actually know what it is to be the Vieta's formula. And Vieta's formula is even more better than the quadratic discriminant, because we can also apply this at any kind of situations in the quadratic function. Also, it takes us short time, and it's also an accurate equation. So let's talk about what is the Vieta's formula, the basic formula of the Vieta's formula. And in a future video, I'll be able to prove why the Vieta's formula became the actual formula that we apply in our quadratic function systems, especially in finding the zeros. So Vieta's formula is formed by the two different things. So it is formed by two different things. The first thing will be the addition of roots. Second thing will be multiplication of roots. It is formed by two things, addition of roots and the multiplication of roots. So if you actually know what is Vieta's formula is, whatever the question that the question maker gave you, we'll be able to solve for less than 5 seconds in order to solve for the roots. So it is formed by either addition or the multiplication, and in the next video we'll be able to prove why the Vieta's formula became the actual formula. But in this case we will think about how we use it. The addition of roots firstly. So let's write it down again. The addition of the roots for the formula from the Vieta's formula. So the addition will be negative b over a, and the multiplication will be c over a. And you may think that what is the a, b, and c? It is all originated from our quadratic function system. So it is originated from the quadratic function system. And we usually notate our quadratic function as y is equal to a. So y is equal to a, x squared plus bx plus c. And we know that there are three different roots, a, b, and c. From these three alphabets, we could make our formula for the Vieta's formula. So we are using our addition in this case. So let's actually apply it to our original function. In order to apply it, we need our function. In this case, it will be our quadratic function. And our quadratic function from the question will be y is equal to 3x squared minus 6x minus 4. So it will be y, or f of x, is equal to 3x squared minus 6x minus 4. In order to apply, we need to think about what are the a, b, and c from our function. Well, we know that the a value will be our leading coefficient. The a value will be a leading coefficient, which defines the types of graphs and vertex in our quadratic function. Second thing will be our b, which is just a coefficient, not a leading coefficient, of x to the first power. And the last thing will be c, which is our y-intercept. So using these things, we could easily figure out that what is the leading coefficient? It will be 3. What is the b coefficient of the x to the first power? Negative 6. What is the c y-intercept? Is negative 4. So again, our addition, formula for the addition will be negative b over a. It is same thing with negative plus just a coefficient over positive leading coefficient. This is what the formula will going to be. The coefficient of our quadratic function, 3. So leading coefficient will be denominator 3. Numerator negative plus coefficient of the x squared x first power is negative 6 plus negative, it will be positive 6. You want to give us the answer Q. So our answer for this question was 2, and as we compare from the last answer, it was exactly C. But if you knew what the formula for Vita's formula was, we could solve in less than 5 seconds, unlike the quadratic discriminant, where we could make a calculation error. So in the next video, we'll be able to prove why the Vita's formula exists, and also addition and the multiplication situations. So we could actually prove and apply our formula into the actual finding zeros, our root, our x-intercepts in our quadratic function problem, because the finding the zeros or the addition between the zeros will be the most frequent question in our quadratic function system problems in SAT.